Today we are going to implement the project of security features on switches. So this is a topology that we are going to basically use. Uh, Here there are two gateway routers. There is an ISP connected to it. Then we have made there are three different switches for it. There is switch 1 which is connected to server PCs. Then there is another switch which is connected to sales PCs. TH1 stands for the technical PCs, and AH1, AH2 stands for the accounts PC. So next step would be we are going to implement password and username in each of the devices. To save our time, I'm not going to write each and every command on the switches and routers. So what I've done, basically I've made a Word file, and from that I'll just copy paste the commands, but I'll explain each of the command in detail. So here what we basically did, we just give a host name to it. We can access the switch through different medium like a console port or telnet. I've given the provision of console 2 and telnet 2. The login local gives us the ability to give password as well as username when we enter. The enable secret Cisco is a command through which we can encrypt the password in MD5 algorithm, so any attacker cannot see that password. We will enable that password and username to all other devices. Next we are going to implement is VLAN. VLAN is a protocol that is established on switches. It is basically used to isolate different PCs from the network. So if I want that only sales PC can talk to a sales PC, and if I want that technical PC can only talk with a technical PC and not with a sales and accounts PC, VLAN is used for that purpose. So basically we are going to establish VLAN on these three different switches. The property of VLAN is that by default every switch is on a server mode. So we have now to convert the other. We'll make this switch as a server switch, and the two other switches we are going to make it as client switches. So we'll be seeing the commands to make it the client mode. Okay, so on DS1 we implemented the command. So this switch we have made into the server mode. The rest all switch we are going to make into client mode. We can see if the switch has gone into the client mode or not by using the command show VTP. So as you can see in this VTP operating mode, you can see it has went to the client. And similarly on the DSW2 switch, we are doing the same thing. And show. And as you can see, this is into the client mode. The DSW1 would be in the server mode. Now we will create some different VLAN for each. As you can see, there is an sales area, technical area, accounts area, and the server area. So on DSW1 we'll just be naming each of them. Okay, so we have created basically different VLANs for different PCs. We can see if that has been established or not. As you can see here, we have established sales, technical, account, and different VLANs. Now if a switch wants to communicate with another switch, it has to establish the trunking port when it needs to talk. So this ports and this ports, we are going to make it on the trunking mode. This ports and this ports here for DSW1 and DSW2. So on DSW1, now we can check the we will see if the trunking port has been established or not. So to see the different VLAN, the command is so as you can see here, the status is trunking for all these different modes. And we have two types of encapsulation. One is 802.1.q and ISL. ISL is a Cisco proprietary and 802.1q is an open standard. We have to assign like which interface belongs to which VLAN. So initially on switch 1 will DSW1 will be looking at. So the first two ports is assigned to VLAN 3. So SH1 and SH2 would be a part of VLAN 2. 3, sorry. And the third port, which has the technical PC, would be the part of VLAN 4. And we can check it by using the command show VLAN. As you can see, the first two ports have entered the sales VLAN and the third port has entered into the technical VLAN. Now I'll be repeating the steps for DSW2 and server ASW. And here, as you can see, we have divided different ports to different VLAN. Later, I've given IP addresses to each of the PCs in such a manner. I'm not going to show you on each PC or it would waste a lot of time. And then to check the VLAN connection has been proper or not, from SH1, I'm going to ping the PC of SH2. So as you can see, we are successfully able to ping. As you can see, the TTL is 64. We are successfully able to ping from one VLAN to one PC from similar VLAN to another PC. So we have been successful implementing VLAN. Theme that we are going to implement is called inter VLAN. So what will happen if sales PC wants to communicate with technical PC? And that's the only feature that you want to turn on. So basically you want inter VLAN connectivity. So the method that we are going to use is called router on a stick. So we will communicate like this. I can show you with the mouse. We'll go through gateway 1, through ISP and through gateway 2, and we will go to another network. For router on a stick on gateway 1, we have to create different sub interfaces on this E0/0 terminal. The sub interfaces are created because it is very costly if you establish physical links on those terminals. So that's the reason why we create sub interfaces. And to check if it has been established or not, we can use the command show IP interface brief. So as you can see, we have established sub interfaces, and similarly we will do on gateway 2. Yeah, here also we have created different sub interfaces. Now I'm going to assign a gateway to each of the interface, each of the PCs here, because as you can see, I need inter VLAN connectivity, and I'm going to go outside from the gateway. So if I want to go outside from the gateway, I need a gateway IP address. So on each PC, as you can see, I've assigned a gateway. Now I'm going to make the this whole connection as a trunk port, because I want to communicate from the switch to the router, and so I've used all commands. uh, as you can see, I've implemented that on DSW1 and DSW2, interface E0/0, interface E0/0. And now I'm going to from my TH2, which is my technical PC, I'm going to ping a PC of any network. Let's take, I'm going to ping a network of 5.1, which is accounts PC. Now what I'm going to do is I'm going to ping from technical PC to a PC from accounts. So I've opened the terminal window of TH2, and from that I'm going to ping address 5.1, which is an accounts PC. So as you can see, there is an TTL coming, which shows us that we are successfully be able to ping the network. And so what we have done here is from one VLAN we are able to communicate with another VLAN. To implement a port security on this switch, here we are going to assign a MAC address on the interfaces. So so if another rogue attacker will come and attach his PC on this interface, then the switch would know that it is not that assigned MAC address that the engineer assigned to it. So then it would disable that particular port. So for that, this is the list of commands. So here basically what I'll explain you each command. The access port, as it is connected with a PC, the maximum shows that how many number of MAC addresses you want to assign to it. This is the MAC address that we have assigned, and if any another MAC address apart from this would come, then the action then it would be taking is shutdown. So basically, we have another two modes also apart from shutdown. One which is called restrict, and the another one is called protect. In protect, it would be just non-allowed frames would be dropped. In the restrict, the frames would be dropped and a security alert would be generated. And in shutdown, the port would be disabled. So to check if we have been successful or not, the command is Yeah, as you can see, the violation mode has been activated as the shutdown. As you can see, we have seen the interface 0/1, and the port security has been enabled. And as you can see, the violation mode that we have assigned, it's called the shutdown mode. So that's all from the port security. Next, we will be moving on to STP. In STP, I am using just slide to explain you a bit about it. Here, if host A wants to send a packet to host B, it will initially send via switch B. The property of switch is to broadcast the packet. So it will broadcast it to A and broadcast it to C. So now the packet at C will also be broadcasted at B, A and C, and the packet at A would broadcast at B and C. So what would this create? It would create broadcast storms inside the network, and the packet would move from each switch to another switch. So the solution for that is to shut down the redundant ports. So if I want to send from host A to B, I'll choose just a path of from switch B to A to C and to B, and I'll shut down the path from B to C. Initially for the STP, there is an one root bridge selected, and it is selected using an STP election. For that STP election, there are 4 states that it has to pass through: blocking, listening, and learning, which accumulates up to 50 seconds. Now we are going to check on our switch. As you can see, the server switch is a root bridge, and all the ports of the root bridge would be in forwarding mode. And similarly, when I check it on DSW2, it has to shut off one of the redundant links here. So as I've given the command here, show spanning tree, and as I could find out, the 5/3 it has went into the blocking mode. So this link would automatically shut down when you enable STP. Uh, there is another thing called port fast. So what happens is when you connect a PC to a switch, as you can see, there have been like 4 modes, so it takes like 50 seconds to turn on this PC. But if you want a quick configuration and eliminate that 50 second, you have to remove that STP from that particular port. So to turn off the STP, there is one feature called port fast, and I've implemented the port fast here on switch ASW. As you can see, spanning tree port fast should be enabled, and as you can see, when port fast is enabled, and it can cause the bridge and loops to turn off. In Uplink fast is a feature of STP. So what does it do is that basically, let's consider this DSW1 switch. It has like 4 terminals: 5/0, 5/1, 5/3, and 5/2. So if 5/0 and 5/1 goes down, then it will take us like 50 seconds from transition from this terminal to the other terminal, because of the learning and listening and blocking state. So to eliminate those time and to quickly turn off the other ports when one of the link fails, the feature that we use there is called like uplink fast, and the command is just simple. I've shown here the STP uplink fast, and as you can see, it has been enabled. You can enable it all the switches. So one of the disadvantages of STP was that, as we have seen, that we have created 2 links here, and so the output that we should get here should be 20 Mbps, that both of them are Ethernet ports. But what would happen due to STP is that one of the port would shut down due to redundancy problems, and at the other side we will only get 10 Mbps speed. So to overcome that problem, we use a feature called ether channel. In ether channel, we will logically combine the both of the links to a single link. The commands are as shown here. So here I've just given an interface range 5-2 and 5-3, and I've just given it then a random number from 0 to 255, and the mode I've selected is on. There are like two modes in ether channel. One is PAGP and another is LACP. The PAGP is Cisco proprietary and LACP is open standard. And similarly I will do the same here at DSW2. Now to check if it has been implemented or not. As you can see here, there hasn't been a group created. And now to check if we are getting the speed of 20 Mbps. As you can see here, we are getting the bandwidth of 20,000 kbps, which is equal to 20 Mbps. And now we would do the same here. As you can see here on switch 1 also we are successfully able to perform ether channel. And here also we are able to get a bandwidth of 20 Mbps. So we have been successfully able to implement ether channel on our topology. Feature that we are going to implement is HSRP. It's called hot standby routing protocol. Here basically what happens is that an ISP gives the connection to gateway 1 and gateway 2. Let's assume that the gateway 1 is an AT&T connection and the gateway 2 is an Xfinity connection. So in case if the AT&T connection goes down, then the ISP router automatically switches to the Xfinity connection. So basically what happens is the main principle is that if one of the active router goes down, the other acts as a standby router. So basically what the initial step is, I've configured IP addresses on E0/1, this gateway terminal, on this gateway terminal, and on ISP on both the terminals of the ISP router. Now we will be giving commands on gateway 1. So we'll be creating sub interfaces, and we'll be assigning an each VLAN an IP address, and then what we have done is we have given a priority to it, as you can see here. And similarly on gateway 2. Now I'll explain you each of the commands. The priority is we have given as 150. This is the IP address that we have assigned. There are two timers here. One is the hold on timer, which is of 10 seconds, and hello timer of 3 seconds. So to reduce the timer, we have used this command. In the next, this is the transition time which is take to go from active to standby. So we have also reduced that to quickly change it. Then in the this command stands for the tracking mode. So what happens is that let's assume that on gateway 1 the connection goes down, so it has to switch over to gateway 2. So the tracking sees to it that the connection is down, and it reduces the priority by 60. So the initial priority was 150, and when you reduce it by 60 it goes to 90. So what happens? It is less than the the gateway 2 priority. The gateway 2 priority was initially at 100. So what would happen that this priority of gateway 1 would go to 90, and then the gateway 2 priority is 100. So the gateway 2 would be selected as an active router. So now to see if it has been performed correctly or not, show standby. As you can see here, the priority has been assigned 150, and all the states have been in active mode. Uh, Now performing on gateway 2.